All right. Welcome back, everyone. Ready for another deep dive.
Absolutely. Let's get into it.
Today, we're going to be shining a light, literally, on light itself.
Sounds illuminating.
You guys sent in, well, a ton of research about light and how it works.
And we've got it all here, ready to break it down.
Yeah, we're going to break it all down.
Yeah.
So first of all, like, what even is light? I mean, we see it every day, but what's the science behind it?
Well, at a very basic level, light is a form of energy. And it travels in waves.
Wave, okay.
Yeah. Kind of like you see at the beach. But instead of water, these waves are made of these tiny little packets of energy called photons.
It's photons, like little bundles of energy.
Exactly. Traveling at, you guessed it, the speed of light.
The speed of light, the fastest speed there is.
That's right.
Yeah.
And it's these photons and these waves that allow us to see the world around us.
Okay, so those waves, they have like peaks and valleys, right?
Yeah.
Like all waves do.
Yeah.
So how does that affect, I don't know, how does that affect what we see?
Well, those peaks and valleys, we call that wavelength. And different wavelengths actually correspond to different colors.
Okay.
That's why we see rainbows, right?
Rainbows, yeah.
It's sunlight being split into all those different wavelengths, all those different colors.
So it's the ways that bring us color.
Pretty much.
But now not everything we see actually makes its own light.
Right.
Like I'm looking at, I don't know, my coffee mug right now and it's not glowing.
That's a good point. We have to separate things that produce their own light, like the sun or a lamp.
Okay, so the sun.
Those are what we call luminous objects.
Luminous, they give off light.
Exactly. But then you have things like your coffee mug, which don't produce their own light.
Non-luminous?
Non-luminous, but we can still see them because they reflect light from somewhere else, like the sun or a lamp.
So it's bouncing off the mug into my eyes.
Precisely. And that's only possible because light travels in a straight line.
In a straight line, okay.
Yeah. Imagine you're shining a flashlight across a room. That beam of light goes straight right.
Right, it doesn't curve.
It doesn't curve.
Yeah.
If it didn't travel in a straight line, well, we wouldn't see the world the way we do, and we wouldn't have shadows.
Shadows, that's a good point. So how do shadows work then, if light's just going in straight lines?
Well, a shadow forms when something blocks those light rays.
Okay.
When an object, especially an opaque one, something that doesn't let light through, it gets in the way of those rays and the area behind it gets darker. That's your shadow.
So it's like the object's cutting off the light.
Yeah, exactly.
And I always think about, shadows, they're not just a scientific thing. Like artists, they use shadows all the time.
Oh, absolutely.
To create depth and realism.
Painters, architects, photographers, they all use light and shadow to create, a sense of space to make things look three-dimensional.
Right. Like I remember I was fascinated with shadows as a kid,
Yeah.
trying to catch them or outrun them,
I think we all did that.
It's like a universal childhood thing.
Yeah.
Okay, so let's talk about how we actually see things. I mean, light is involved, obviously, but what's the process?
Well, for us to see something, light from that object has to enter our eyes.
Okay, that makes sense.
And our pupils, those black circles in the middle of our eyes, they control how much light gets in.
Right.
It's like, the aperture on a camera.
Okay, so the pupil is like the gatekeeper.
Exactly, letting in just the right amount of light.
But, okay, so we see some things clearly, like if you're looking through a window.
Yeah.
But other things are blurry, like if you're looking through frosted glass or something. Why is there a difference there?
That has to do with how different materials interact with light.
Okay.
There are three main categories we can talk about: transparent, translucent, and opaque.
Okay, so transparent, that's like the window, right?
Exactly. Transparent materials, like a clear window, allow light to pass through without being scattered much. That's why we can see clearly through them.
So you can see right through it.
Yep.
What about translucent?
Translucent materials, think of like frosted glass or a thin sheet of paper.
Okay.
They let some light through, but they scatter it in all different directions. So you can see light coming through, but you can't see shapes clearly.
So it's blurry.
Exactly. And then you have opaque materials.
Okay.
Things like a wooden door or a brick wall, they block all light from passing through.
They don't let any light through, so that's why you can't see anything on the other side.
Precisely.
Okay, that makes sense. And you mentioned mirrors before, and that makes me think of reflection.
Reflection. One of the most interesting things about light, it's when light bounces off a surface.
Bounces back. So like when I look in a mirror.
Exactly. You're seeing light that bounced off your face, then off the mirror, and then into your eyes.
It's like a game of light ping pong.
You could say that.
But why do some things, like a mirror, give you a clear reflection, but other things don't.
That's because of the surface. A smooth surface, like a mirror, reflects light in a very uniform way, so you get a clear image.
Okay.
But a rough surface, like a wall or a piece of fabric, scatters the light in lots of different directions. That's why you don't see a clear reflection.
So smooth surfaces are like organized bouncers,
Right.
sending the light back in a neat, straight line.
Exactly.
And rough surfaces are more chaotic, scattering the light all over the place.
A great analogy. It's interesting. Historically, mirrors have always had this, almost mystical quality.
Oh, yeah. Definitely.
In some cultures, they were seen as portals to other worlds.
They do feel kind of magical.
Yeah. And speaking of mirrors, they can be used for, more than just checking your hair.
Oh, right. Yeah, like in those periscopes they use on submarines.
Exactly. Periscopes use mirrors to bend light, letting you see around corners or over obstacles. It's all about understanding how light reflects.
That's so cool. So mirrors, they're like light traffic directors.
Yeah, they send light where you want it to go.
That's a great way to put it.
Yeah.
Okay, so our research also mentioned something about angles, like the angle of incidence and reflection. What is that all about?
Yeah, that's a key concept. Basically, it says that when light hits a smooth surface, the angle at which it hits, the angle of incidence, is the same as the angle at which it bounces off, the angle of reflection.
Okay, hold on. So light always travels in straight lines, right? We talked about that earlier.
Yes.
But what about when light goes through water? Doesn't it, like, bend?
You are absolutely right. That's a phenomenon called refraction. Light travels in a straight line through one medium, like air. But when it goes from one medium to another, like from air to water, it changes direction.
So that's why a straw looks broken in a glass of water.
Exactly. The light bends as it passes from the water to the air. It's not actually broken. Just looks that way because the light is changing direction.
So it's not breaking any rules. It's just taking a detour.
You could say that. And it's this bending of light, this refraction, that makes things like lenses and eyeglasses possible. It's how we correct vision problems.
Oh, wow. That's incredible. So we've got reflection, we've got refraction, we've got these tiny photons traveling at the speed of light in waves. Light is complicated.
It definitely is, and there's so much more to it than we can cover here.
Yeah, but I feel like we've covered a lot.
Oh, absolutely.
And hopefully our listeners have a better understanding of how amazing light really is.
And hopefully they'll go out and observe light in the world around them a little differently now. See the reflections, the shadows, the way light interacts with different materials.
It's all around us. It's like a constant light show.
It really is.
All right, well, that's about all the time we have for today's deep dive.
Until next time.
Keep those research questions coming, and we'll see you all next time.
Bye.
See you later.